A giant cloud in outer space, a nebula. This one is called the Horsehead Nebula. Nebulae, made mostly of gas and dust, do resemble clouds. The Eagle Nebula features these three pillars of creation. Just the tip of one of those horns is big enough to accommodate our entire solar system. The Carina Nebula. Space is by no means an empty vacuum. It's filled with interstellar gases and cosmic dust. When the gases and dust clump together, the result is a nebula. Obtaining distinct images of these nebulae has been one of the great contributions of the Hubble Space Telescope. The Hubble has devoted over 100 hours to the observation of one nebula in particular. Winter is the time when the constellation Orion shines forth most beautifully in the northern hemisphere. Connect the dots of the constellation stars and you get the figure of Orion, a hunter described in Greek myth. Below the three stars of Orion's belt, you can spot the edge of his sword. That's what Hubble focused on. This mosaic combines 100+ images of that region, pieced together over a 2-year period. What emerges is a detailed picture of the Orion Nebula. It's enormous. Just the vertical dimension, as shown here, extends 12 light years. At its center, 4 young stars, each equivalent in mass to more than 15 of our suns, form the main components of a cluster called the trapezium. The sheer brilliance of the trapezium lights up the Orion Nebula in a blaze of glory. It is said that at one time or another, every telescope in the world has been trained on the Orion Nebula. It's thought to hold the key to a riddle everyone wants to solve: how stars are born. If one really could voyage into the depths of the Orion Nebula, what sort of cosmic scenery would unfold? With Robert Odell as our expert guide, let's go sightseeing ourselves. The Lick Observatory is located in the mountains just east of San Jose, California. A century ago, it boasted the first telescope in the world to be erected on a mountaintop. And in 1963, it was here that Robert Odell, then a newly minted college professor, made his first professional observation of the Orion Nebula. These are two of Odell's former students and research assistants. Manuel Peimbert Sierra became a university professor himself and still conducts research on the Orion Nebula. His wife, Sylvia Torres Peimbert, also does nebula research at the university.
And Mount Hamilton is such a beautiful site.
Right.
The most interesting thing is that it is the star-forming region that is closest to us, and that, therefore it has been studied very thoroughly. We can know more details about it than that we can learn from other gaseous nebulae.
It's a Rosetta Stone, or a cornerstone for the study of the universe. And in addition to that, it's very beautiful. So if you see the images of Orion, many of the amateur astronomers get in love with astronomy by looking at the Orion Nebula.
The three astronomers used to come here every winter to conduct their own observations. The Orion Nebula appears at first to lie within the Orion constellation, but actually it does not. The nebula is farther away, 1,500 light-years from Earth. And since it's located in a different part of the night sky from the star-rich Milky Way, it's relatively easy to observe.
Wow. The telescope looks the same, but like us, maybe it shows that it's a little older, and it has been 50 years older and out in the rain, out in the cold.
It looks like a movie of the 40s.
Yes.
Wow.
Just as I remember, and then of course there's the declination.
These yellow pages, which is my observing.
Odell still carefully preserves his observation logs from his early days.
At the Pine Bluff Observatory. Our first observations of Orion were made in October of 63.
Yes.
So.
Wow, that's outstanding.
Yeah, so.
During these observations, Odell realized something important. It was the key to a major discovery later. Odell made a study of the composition of the gases in the Orion Nebula. He noticed small amounts of cosmic dust mixed in with the gases. Differentiating gas and dust proved crucial. A nebula is comprised mostly of hydrogen and helium gas. The gases concentrate into light-emitting stars, like our Sun. But there's dust, too. Matter such as silicon and nitrogen. And all this dust turns out to be crucial to the creation of planets, such as Earth.
It just caused a fundamental change in how people looked at these regions where stars were formed. If they didn't have dust in them, then you'd probably only form a star and might never actually form planets around it.
By observing the Orion Nebula, Odell realized he ought to be able to witness the birth of both stars and planets. He's been doing just that for 50 years. Odell was just 13 years old when he first saw the Orion Nebula. He says he saw it as just a hazy mist. Neither of Odell's parents had much schooling. They worked all their lives. But Odell says they were determined that their children would be well educated. The family's finances were precarious, but they scraped together enough to buy this book on how to make your own telescope. Using cardboard boxes and other materials close to hand, the young Odell managed to construct a working telescope. With it, he saw the Orion Nebula.
Looking at things yourself that were beyond the Earth seemed fascinating. The ability to essentially travel outside the Earth for the price of building your telescope just seemed wonderful.
Odell wanted to view the Orion Nebula in greater detail, and he began to take steps to make that dream a reality. In 1969, the American Apollo program succeeded in landing men on the moon. By the 1970s, NASA was vigorously pursuing new objectives in space development. A team was assembled to develop a new project. The team included just one astronomer, Robert Odell. Recruited into NASA from academia, the ex-professor became one of the chief advocates of an extraordinary plan: to put a large optical telescope into Earth orbit. Odell's friend at the time, Lyman Spitzer, had already proposed the concept of a space-based telescope. The two of them often conferred on the subject. In 1977, 3 decades after Spitzer's original proposal, construction began on the Hubble Space Telescope. The primary mirror was 2.4 meters across. In addition to acting as project scientist, Odell personally took charge of the design and development of some of the instruments critical to observation, the telescope's cameras. This one, about the size and shape of a grand piano, was Hubble's main camera. In space, where there are no atmospheric fluctuations, this camera could take images of unprecedented clarity and detail.
3, 2, 1, and liftoff of the space shuttle.
In April 1990, a space shuttle finally lifted off with the Hubble Space Telescope aboard. Odell and 2 daughters witnessed the launch.
It's a very emotional experience because at that time I had been working on the Hubble, first as an advisor, for 19 years.
The Hubble Space Telescope was deployed into a low Earth orbit of 600 kilometers.
We're looking at a star.
A month after launch, Hubble sent back its first images.
Yes.
But everyone's great expectations were dashed. Hubble's fuzzy images proved no better than those taken from Earth.
Pretty horrible. Just a shock of, something, knowing that something was wrong.
After the expense of vast sums of money and 20 years of labor, the scientists' dreams seemed lost in space. Odell and his colleagues now searched desperately for the cause of the aberration. They found that the primary mirror had been shaped too flat toward the outside. The deviation measured 0.0003 millimeters. At this point, there was no way to replace that huge mirror. In December of 1993, a space shuttle was sent up to service Hubble, an attempt to convert despair back into hope. One servicing objective was to swap out that main camera array for a new one that Odell helped design. It included optics modified to help compensate for the telescope's misshaped mirror. "20 days later, Hubble sent back new images. This is how Hubble saw galaxy M100 before servicing. And this is after servicing. A much clearer picture of a galaxy more than 52 million light-years from Earth. Never before had a galaxy so far away been observed so distinctly.
It was perfect. It was better than the contract called for, which we knew it should be, before this problem with the test device. So it was great. It is as good a telescope, image-wise, as a telescope of that size can be.
With a new lease on life, the Hubble Space Telescope opened one new window after another onto the mysteries of our universe. Hubble was now repaired and even enhanced with corrective optics, but Odell's own research plans ran into a new snag. Hubble telescope time was strictly rationed. Priority went to those who had contributed the most to its development or who had already achieved distinction in astronomy. Despite his own early advocacy and his role in Hubble's development and deployment, Odell himself had been granted no telescope time at all. Odell had devoted 20 years to this project because he wanted a better view of the Orion Nebula. Now others were getting first use of the revolutionary telescope he had worked so hard to deploy. It was hard on him. Around that time, a meeting was held by the astronomers who had been granted telescope time on Hubble. After the meeting was finished, Odell was handed an oblong plate of metal.
This is one of my most prized possessions.
It's now a plaque decorating his office. The inscription, signed by 50 scientists who had been given time on the Hubble, reads as follows: "To Bob Odell, for outstanding service 1973 to 1983, we award a guarantee of space telescope time."
Unknown to me, the 50-odd scientists who did have guaranteed time voluntarily each gave me part of their time, and collectively it gave me the same level of reward. It was an absolute surprise to me, and just a wonderful surprise.
Collectively, Odell's colleagues had given him some 40 hours of work time on the Hubble Space Telescope. But Odell himself had a generous plan for 20 of those hours.
And that one half I offered to Professor Lyman Spitzer, who was a personal friend and who was the person who had originated the concept of the Hubble Space Telescope.
Spitzer had similarly been left out of the initial award of observation time on the Hubble telescope. Now the two visionary men, with 20 hours each, could realize their personal dreams of using a space-based observatory. After that first servicing mission, Hubble still needed adjustments before observations could begin formally. The Orion Nebula, which is large and bright, was chosen as a target for testing. Odell knew about that and requested a highly specific imaging target. It was a region he had become interested in during his work at the Lick Observatory. This is the test image Odell took of the Orion Nebula. There was something in the vivid image that astonished him.
Of course, we were very concerned that this was some type of artifact introduced by the computer program. But once we became confident that the images we were getting were good ones, then just like that, it was clear what we were seeing, that we were seeing protoplanetary disk around other stars.
It did look potentially like gaseous clouds whose shape had altered by chance. However, since this was the Orion Nebula, where cosmic dust was present, the image could be showing the birth of planets. Odell became convinced that indeed this image recorded the very moment of their creation. In 1994, Odell was finally able to use the Hubble time he had been given by his colleagues to conduct whatever observations he wished of the Orion Nebula. This was his earlier test image. Now, Odell was able to examine a region 10 times larger. 4 stars shine brightly near its center, the heart of a star cluster called the trapezium. Let's take a closer look. A cocoon-like form emerges, the kernel of a star, enveloped in gas and dust. It's even more distinct than the image obtained during the test. And the new image can be processed and refined further still. There's something inside that cocoon, but what exactly is it? A star like our Sun emerges as a concentration of gases in space. Eventually, the central portion of the gas concentration heats up, and a protostar takes shape. Swirling around it is a disk of gas and dust that can, in time, become planets. It's a dynamic situation, to say the least. From the center of the disk erupts a perpendicular jet of stellar material. It is so powerful, it extends trillions of kilometers into space. The potentially planet-forming swirl of gas and dust is called a protoplanetary disk, proplyd. The dust surrounding the protostar collides with other dust particles, combining into larger bodies. Gravitational forces assist this process of repeated collision and amalgamation, and eventually planets are born, like our own Earth. At the core of the protostar, nuclear fusion sets in, producing tremendous amounts of heat and light. All that force blasts away the remaining nearby gases. What's left is a new solitary star glowing in space. Its stellar jet and a proplet, or protoplanetary disk, carrying the raw materials of future planets, all enveloped in a cocoon of gas and dust. The proplet thus occurs in the stage prior to the birth of planets like those in our own solar system. A number of proplets have been discovered in the Orion Nebula, but their shapes and colors are quite varied. Why should this be so? This graphic provides a sideways look at the Orion Nebula. The stars being born in that concave part facing Earth generate heat and light which illuminate the cloud beyond. A thin curtain of gas and dust called Orion's Veil partially covers this star and planet-producing region. So when the bright light of Theta 1c shines on a proplet behind it, the proplet and its cocoon of gases are fully lit and clearly visible. In this case, with the proplet more toward the front and side, the gases appear to trail away from Theta 1c. Here, light from Theta 1c is screened out by the gases of the proplet, so we see the proplet in silhouette, with its own protostar glowing red in the center. So the apparent differences among the proplets depend on their location. Once Odell understood these differences, he was able to determine the structure of the Orion Nebula itself. In 2004, Odell was able to conduct an unprecedented large-scale observation of the Orion Nebula. This was his previous image. Now he expanded the area under observation tenfold. Utilizing the Hubble Space Telescope for more than 100 hours, he took more than 100 images. Then he spent 2 years piecing them together precisely. The final image is a square, 12 light years on a side. Swirling gases glow vividly with reflected light. Here and there can be seen newborn stars. The same composite image reveals new proplets. The disk of gas and dust enveloping this protostar shows in dramatic silhouette, thanks to light from an established star. More than 200 proplets have been observed in the nebula so far. Many stars can be seen in the very moment of their birth, making the Orion Nebula a precious stellar nursery. This is Mexico's Baja California Peninsula. Located in the northwest of the country, it extends deep into the Pacific Ocean. On a 2,800-meter high mountain peak here is located the country's National Astronomical Observatory, operated by the National Autonomous University of Mexico. For a number of years now, this observatory in Sierra de San Pedro Martir has been Odell's home base of operations. Here, together with theoretical physicist William Henney, Odell has been studying the behavior of gases in the Orion Nebula. They have made a new discovery. In the images taken by Hubble, Odell noticed unusual forms resembling ripples. This is the first image ever showing cosmic shock waves. These are bow shock waves, phenomena created, it is believed, by the jets of gas and dust erupting from the newly formed protostars. Odell found many of them occurring in the presence of protostars.
Bow shocks are where gas is pushing against gas, and it forms a thin layer that is heated up and becomes very visible.
Over a long period of time, the bow shocks spread out like ripples. Odell has been cataloging the various patterns they form as they spread. The largest telescope at San Pedro Martir Observatory has an aperture of 2.1 meters. It was equipped with an excellent spectrometer specifically in order to observe interstellar shock waves. By comparing and analyzing images from the Hubble and San Pedro Martir observatories, Odell and his colleague were able to determine the speed and direction of some of the bow waves.
Things are moving in Orion, and what we found was that these objects, where you see the lines, are moving in space, and we see this all over, and they're all expanding away from a region here in the middle.
The shock waves originate in a specific region. That's where the protostars producing the shock waves tend to be concentrated. It's like a star factory, turning them out one after another. Odell has dubbed this region Orion South. Orion South is a region of dense gases, to the lower right of the trapezium in this image. The stars born here spread out into the Orion Nebula.
We knew that something was going on inside that region. That is, that was a new area of star formation.
Odell is now at work at what will be the crowning glory of a 50-year career in astronomy. And there's a deep connection to a cherished hobby. Odell loves to work with his hands, everything from building telescopes to cooking. One of his hobbies was an unusual one. Over the years, his wife Sally could not entirely escape being involved in it.
And then one of the problems was he loves to fly, and he had an airplane. I barely do big jets. I mean, I am, a basket case before I get on an airplane. So I did fly with him a few times, but he could tell I was really nervous.
Odell didn't just pilot airplanes, he built his own, and he flew them. He also became skilled in aerobatics. He participated in competitions and won many prizes. That engineering knowledge and skill also found expression in his work to get the Hubble Space Telescope up and flying. Odell no longer pilots planes himself, but he does dream of flying at will through the Orion Nebula. To make that new dream a reality, he's compiling a virtual 3D map of the nebula, and he's excited about it.
There is a rush, no doubt about it. To me, the freedom of motion, of moving in 3 dimensions, which we don't have as humans.
The most difficult part of converting telescope images into a 3D map is determining distances precisely. We know the Orion Nebula is 1,500 light-years away from us, but we have had no way of measuring the topography within the nebula. What looks like a flat surface must be as complex as a mountain range.
Here.
Odell relies greatly on Gary Ferland's expertise in theoretical astrophysics.
The star cluster had been on the other side of this great big molecular cloud.
One of the simplest things you've done is the thing that, to me, has been most useful, because that's what allowed us to determine that this was a big bowl here, and that this part over here was like a canyon, a straight wall along here.
Ferland developed a special method to be used in building a 3D computer model of the nebula.
Here's the coffee cup, a beautiful coffee cup. In astronomy, we can look at things, but we cannot do that. We cannot look in different directions. And so we have to find very, very clever ways to do that sort of thing.
Ferland discovered a correlation between the brightness of a star and the brightness of the nebula behind it. And from that, he can figure out how to calculate the shape of the nebula. For example, here are two stars of equal brightness, but one has a bright nebula background, and the other a rather dark background. The difference is due to the different distance between each star and the nebula. Ferland detects slight differences in background brightness and combines those findings to develop the three-dimensional shape of the nebula.
Too much often in astronomy, we just get the two-dimensional image, like a still picture on the sky. And we live such a short time, only 100 years, we don't see things changing. But actually what's going on out there is very dynamic. Things are happening. It's very three-dimensional and beautiful to look at. And this fly-through makes it possible for a person to actually see what it would be like if we could build a starship and go out there and see what's going on.
Using this method, Odell was able to clarify the three-dimensional shape of the Orion Nebula. If he could travel through the nebula himself, he knows where he wants to go.
Actually, there are two places I'd like to go. One is close to one of the particular proclids, one that's very spectacular object. It would be spectacular to visit. The other region would be in the veil, that the part that we can see most clearly by the kind of dark thumb that points in on the left from the pictures. The idea of going to a stellar nursery at its earliest stages would be very attractive.
All aboard! The Odell Orion Tour is ready for departure. The Orion Nebula, glowing blue and green, a shimmering cloud in deep space. We can't see it like this from Earth, but in the computer, we can approach it on its own level. This central area is 1 light-year across. At the bottom of a giant concavity shine the 4 main stars of the trapezium. Shock waves ripple all about this great basin. We approach the dark veil, dense with gases and dust. Our eyes cannot penetrate this darkness. It is in such dark regions, however, that stars are born. Now we're flying over a shimmering cloud canyon. Off to one side are the 4 brightest stars of the trapezium, the Orion Nebula's main source of illumination. The very brightest of them, Theta 1c, is 100,000 times brighter than our Sun. The surrounding gases are heated to 1 million degrees Celsius. Now, a new cloudy mass comes into view. This is the star factory Odell calls Orion South, and it's one of the places on his personal sightseeing list. It used to be considered a hilly region of the nebula, but Odell's latest research shows it to be a detached structure. Another site Odell wanted to see close up is one of the proplyds, or protoplanetary disks of gas and dust, centered on a newborn star with a stellar jet erupting perpendicularly in both directions. This proplyd is donut-shaped. Within it, a planet like Earth might be forming. An entire solar system could be in the making. What we can see is only a portion of the Orion Nebula. Hidden in its cloudy realms are over 300 massive stars, each shining as brightly as those in the trapezium. And even more are continually being formed. Within 1 light year of the center are some 1,500 newly minted stars. The Orion Nebula, a veritable star nursery. This virtual tour has been the summation of Robert Odell's half-century of research on the Orion Nebula.
And it was spectacular. You could see those blue stars, those pale blue stars, the trapezium stars in the middle. And then you look more and you can see the color in the nebula itself. It's just an awesome picture, and it's still vivid in my imagination.
Hubble has already surpassed its expected 15-year service life by more than 5 years, and it's still sending back a stream of distinct, vivid images. As an astronomer, Robert Odell devoted enormous efforts to making the Hubble Space Telescope a reality, and to advancing the study of the Orion Nebula, the object of his gaze ever since he was a child. Odell's enthusiasm is echoed by astronomers around the world who share in his success and strive to learn more.
Because there always seems to be new problems, new things that we don't understand. And that's the nature of science. You learn something and then you see there's something over the fence that you don't understand, so you move forward, you answer those questions, and piece by piece, you hope you're approaching the complete picture.
The Orion Nebula is a treasure trove of both questions and answers. With every new telescope, the Orion Nebula will surely be the subject of further observation. It will continue to fascinate as a source of great astonishment and intriguing mystery, a challenge and a joy for generations to come.